Welcome everyone to this explainer. I want you to think for a second. Are the rules of physics just lines of code? Are the particles making up your body literally just highly rendered pixels? Well, okay, let's dive into this because today we are going to investigate the fundamental nature of reality itself. We're going to explore the very architecture of what you consider real, bridging some cutting-edge philosophy, iconic cultural metaphors, and hard quantum mechanics to see if the universe is exactly what it appears to be, or maybe something entirely different.
Take a second right now and really look at the device you're using to view this explainer. Go ahead. Feel the weight of it in your hands. Feel the chair you're sitting in. You assume these objects are solid, independent, and absolutely real, right? But I've got to ask you a deeply uncomfortable question. What if your basic assumptions are just wrong? What if literally everything around you, everything you have ever known, is actually an elaborate illusion?
Here is our roadmap for today, taking us from philosophical probability straight into hard quantum physics. 1. Are we in a simulation? 2. The matrix as a metaphor. 3. The quantum reality problem. 4. Einstein versus Bohr. And finally, 5. Testing bounds of reality.
All right, let's kick things off with Section 1, Are we in a simulation?
Back in 2003, philosopher Nick Bostrom published a landmark paper with a highly provocative idea. He proposed that our universe might literally be a computer program. Now, to wrap our heads around this, we first need to understand a concept called substrate independence. Basically, this is the idea that mental states, your consciousness, your thoughts, your feelings, they don't strictly require a biological carbon-based brain. As long as the structural and computational processes are perfectly replicated, a conscious experience could exist on a completely different substrate, like, say, a silicon computer processor. In short, carbon isn't strictly necessary for a mind to exist.
Now take a look at this mind-boggling number, 10 to the 42nd power. Bostrom points out that this is the estimated number of operations per second that a technically mature post-human civilization could pull off. I mean, imagine a computer the physical size of the planet Jupiter. With that absolutely unfathomable processing power, a future civilization could easily run what he calls ancestor simulations. These would be highly detailed, fully conscious simulations of their own evolutionary history, packed with billions of artificial minds that genuinely believe they are flesh and blood human beings.
Bostrom distills this fascinating concept down into a clean trilemma, 3 distinct propositions, and he argues that at least one of them absolutely must be true. Scenario 1, the human species goes extinct before ever reaching that advanced post-human stage. Scenario 2, advanced civilizations simply lose interest in running these ancestor simulations. Maybe they just play immersive video games instead of running complex historical simulations of their ancestors. But if both Scenario 1 and Scenario 2 are false, we are left with the sheer statistical probability of Scenario 3. Because there would be billions of simulated minds for every single biological mind in existence, statistically speaking, we are almost certainly living in a computer simulation right now. Mind-blowing, right?
Moving right along to Section 2, the matrix as a metaphor.
Okay, so that is some pretty dense, unsettling philosophy. Let's ground it in a cultural touchstone you likely recognize. In the 1999 film, The Matrix, the character Morpheus explains to the young hero, Neo, that his late 20th century world is completely fake. The reality he knows is actually a neural interactive simulation, a giant computer construct designed to contain, control, and exploit human beings. As Morpheus so eloquently puts it, it's a prison for your mind.
Now, scholar Alison Cook-Sather actually uses this film as a powerful analytical lens. She argues that The Matrix serves as a brilliant metaphor for the unseen societal systems that unconsciously program us every single day. Take formal education, for instance. She notes that our dominant educational models often treat schooling as a form of social control. Look at how students are processed, like literal widgets on a conveyor belt, treated as quantifiable products on an assembly line, or even viewed as diseased beings in need of a cure. Just like the Matrix itself, these deeply ingrained systems render a particular, restrictive version of reality as unquestionable truth. Which brings us to Section 3, the quantum reality problem. So, we've talked about simulated universes and cultural metaphors, but what about the hard science of our actual physical universe? Well, Jim Baggett's text on quantum mechanics introduces a bizarre twist. It turns out, at the microscopic level, physical reality is incredibly unfixed. At the heart of this is wave-particle duality and the quantum measurement problem. In quantum mechanics, a system is described by a wave function. Think of it like a coin spinning in the air. It's not heads or tails yet, it's just this blur of probabilities. But the mere act of trying to measure that system, like slapping the coin down onto a table, to ask the particle what it's doing, forces that wave function to collapse. Suddenly, the particle randomly chooses a definite state,
like a spin pointing up or down.
So the crucial point is summarized perfectly by the Copenhagen interpretation, which was famously championed by physicist Niels Bohr. Bohr suggested that a quantum particle simply does not exist in any specific measurable state until it actively interacts with a measuring device. In other words, objective reality at the microscopic level does not exist independently of an observer. The act of looking literally creates the reality.
That naturally leads us into Section 4, Einstein versus Bohr.
As you can imagine, this radical idea sparked a massive historical clash between two absolute titans of physics. The implications were just too uncomfortable. On the left side of this debate, we have Albert Einstein. He proposed the EPR argument, insisting on a strict objective reality. He strongly believed particles had hidden variables, like a secret predetermined script dictating their behavior way before we ever measure them. On the right side, we have Niels Bohr and the Copenhagen interpretation, defending a relational reality, where the universe is fundamentally indeterminate and blurry until it is actually observed. And this brilliantly illustrates exactly what they were fighting over. Looking at these dense mathematical wave functions and the EPR argument, you can see why for decades this was a massive scholarly and philosophical deadlock. Einstein just couldn't stand the idea of a universe that only existed when you looked at it. But then, in 1965, physicist John Bell formulated some mathematical theorems known as Bell's inequalities. This was a total game-changer, because it meant physicists could finally build an actual physical experiment to test if Einstein's hidden variables existed, or if Bohr's bizarre relational universe was the real deal.
Now for the really fun part, Section 5, Testing Bounds of Reality.
Let's look at the actual experiments from the 1980s that settled this legendary debate once and for all. In 1981, physicist Alain Aspect, Philippe Grandier, and Gerard Rogier set up a truly groundbreaking experiment in Orsay, France. They generated pairs of correlated photons and sent them propagating in completely opposite directions. They sent them toward different polarizers. You can think of them kind of like high-tech sunglasses for light. The goal here was to see if the photons had predetermined polarization states, just as Einstein argued, or if their states only became real upon the exact moment of measurement. And here are the staggering results. The experimental data clearly violated Bell's inequalities. These findings definitively prove that Einstein's hidden variables failed completely. Bohr's Copenhagen interpretation survived the ultimate test. The photons were mysteriously, inherently connected without any underlying predetermined script. The inescapable summary of all this is, reality is not independent but relational. We are forced to confront the absolute fact that a quantum particle cannot be said to physically exist in a defined state until it interacts with a measuring device. Just like Morpheus's Matrix or Nick Bostrom's Jupiter-sized computer simulation, the solid physical reality we think we inhabit is deeply relational, totally observation-dependent, and in a very real sense, a constructed illusion.
Which brings us to the ultimate twist. Okay, so we know observation collapses the wave function, right? But what exactly happens to the other possible outcomes that the particle didn't choose? Well, in 1957, physicist Hugh Everett proposed a totally mind-bending solution. The wave function doesn't just discard the other possibilities. Instead, it projects into all possible final states. Every single possible outcome is actually realized. The very act of measurement causes reality to split, branching off into physically separated parallel universes. And wow, this brings us right back full circle to Nick Bostrom's theory of countless simulated realities running simultaneously. So, I'm going to leave you with this final, lingering thought. If every quantum interaction causes the universe to branch, and reality only exists as it is relationally observed, are you just a slight variant of yourself sitting in that exact chair reading this explainer in just one of countless branching universes? Keep questioning your reality, keep questioning the systems around you, and as always, keep learning.